I'm here at the Virtual Reality exhibition at Olympia in London. With me is Michael Emsley, who is one of the exhibitors. Michael, there's obviously an enormous amount of interest in VR. Do you think it can live up to people's expectations?
That's a very good question. I think most people do expect far more from VR than it can give them, at least for the present. And this is largely due to the way the media have presented it.
So, what should people expect from it?
Well, they shouldn't expect to be able to have a holiday abroad without leaving their living room, which is what quite a number of visitors today seem to think. VR should be seen as a means, not an end.
What exactly do you mean by that?
I mean that it should be seen as an enabling technology. The potential applications are as diverse as robot operation in contaminated nuclear power stations, recreating crime scenes for the police, helping people with physical disabilities, and curing psychological problems.
In other words, the ultimate interface between humans and computers.
Potentially, yes.
How long do we have to wait for these possibilities to become realities?
Another good question, but difficult to answer. One thing is certain, though. If VR doesn't start producing results soon, then it's likely to run into the same problems as artificial intelligence.
Meaning?
Meaning that if there are no results soon, industry will stop investing in it. Then it certainly won't fulfill its potential.
So, where is the technology at the moment?
Well, the virtual worlds we can create today are still a long way from resembling the real world. This is mainly because of the visual system. Even the best VR display gives only a fraction of the detail of human vision.
How is the display created?
Most VR vision systems are headsets that block out everything except two liquid crystal display screens, one for each eye. Using a technique learnt from artificial intelligence work on vision, the images on each screen are distorted and displaced, giving the illusion of a three-dimensional view.
What happens when the person moves his head?
The movements are detected by three electromagnetic coils. One coil for movements up and down, one for left and right, and one for movements forwards and backwards. This information is digitized and passed to the computer, which then updates the data it holds on the position of the headset. Once the new position of the headset has been calculated, the visual display is updated.
It sounds like a long process.
It's only a matter of milliseconds, but there is still enough of a delay to be noticed by the person wearing the headset.
How much computing power is needed to operate a VR system?
Even an unsophisticated visual system needs a processor able to handle about 120 megaflops. To make what I would call a reasonable visual system would require a processor able to handle 1,000 megaflops. And that's expensive.